All right, this is a big one. So if you remember systems of equations from Algebra 1 and then later in Algebra 2, Algebra 1, they're usually fairly straightforward because in Algebra 1, we usually just do 2 by 2 systems. And then in Algebra 2, of course, we get some 3 by 3 systems. You've learned a handful of methods. We're actually going to learn another 1 or 2 methods this year as well. And so we're gonna hit this heavy. This is not gonna be remotely the last time we talk about excuse me, it's not remotely gonna be the last time we talk about systems. So we're gonna kind of fly through some examples to hopefully dust off cobwebs of stuff you do already know. And then later we will hit it again just in the regular course of this course. So we're going to do this first one. We're going to solve by substitution. Honestly, this particular lesson is probably another one that if I wanted to, I could probably split this up into multiple videos as well, but we're gonna go ahead and squish it all into one and see what happens. So we'll solve this one with substitution. Our example 1 is going to be 2x plus 3y equals 9 and 5x minus y equals 14. So if you remember, to solve by substitution, we first step have to take and solve one of the 2 equations, or 3 equations if we're doing that, for one of the variables. Now this one, it's already pretty set up to solve this second equation for y. So that's what we're going to do. We're going to head and solve this one for y. So we're going to subtract 5x on both sides. So this cancels, leaving us with negative y. Don't forget to bring that in that negative. That would be an easy place to make a mistake, right? Bring out our 14 minus 5x. We cannot combine those, of course, because they are not like terms. We got to get rid of this negative. Excuse me. If there's nothing there, it's a 1. That negative 1 is multiplied. So to get rid of it, we're going to divide both sides by negative 1. Those cancel, leaving us with just y. Great, grand, and glorious. 14 divided by negative 1 is negative 14. Negative 5x divided by negative 1 is plus 5x. If you want to rearrange this the other way around, be my guest. In this particular problem, that's only going to help so much anyway. So the next step in solving by substitution is to substitute. Imagine that. We are going to take and we are going to substitute this mess that equals y into the other equation for y, right? I'm going to substitute that in right there. So for that guy, we end up with 2x plus 3 times negative 14 plus 5x equals 9. So now we got to solve for x. So we got one variable, one equation. We're going to go ahead and distribute that 3. So we end up with, bring the 2x down. 3 times negative 14 is negative, was that 12? It's the afternoon. My brain doesn't work well in the afternoon. I'm going to sanity check just so I don't accidentally write something down wrong. So how about negative 42? Not that I won't write things down wrong. I've probably already done it at this point, at some point in these videos, but this turns into 15x. But why not take a sanity check? No big deal, right? So now we're going to combine like terms real quick. So combining like terms, we end up with 2x plus 15x. We can also probably go ahead and add 42 to both sides as long as we're keeping it nice and neat and organized. Using our different color helps. Not a requirement, but a recommendation. Those cancel, right? So 2x plus 15x gives us 17x. Excuse me. 9 plus 42 is 51. If I'm not greatly mistaken, 51 divided by, that ends up with, once we divide the 17 off, we end up with x equals 3. Okay, so there's one piece of our puzzle. Now we're going to substitute again, to get the y. We can substitute into any one of these equations, this number. You want to substitute it in wherever it's going to be easiest. So in this particular case, it's going to be easiest to go ahead and substitute it right there. Excuse me. Because that one's already solved for y. We already did that work. We may as well utilize it. Y equals negative 14, plus 5 times, we're substituting in that 3, negative 14, bring it down. 5 times 3 is 15. That 4 went a little bit wacko. I'm having trouble with 4s all of a sudden. Oh, well, no big deal. Negative 14 plus 15 is 1. So our answer here is the ordered pair, 3, 1. So there's a reminder of solving by substitution. That's not that big a deal. Let's do a second example. This time we are going to solve by elimination. Okay. All right, this is example number 2. Let's see. Let's do 1.5x plus 2y equals 20 and 2.5x minus 5y equals negative 25. Okay, so that 2 went a little crazy. I got distracted. There was yelling going on upstairs. I got distracted. That 2 is turning into a swan. That kind of looks cool, but there it is. Here we go. Now, in order to solve by elimination, our first step is to get 2 of the variables to be opposites, right? So we could make the x's opposites or the y's opposites, either one. So what we're going to do, since these 2 already have the opposite sign, we're going to go ahead and make the y's opposite. So in order to do that with these guys, what we're going to do is we're going to multiply the top one times positive 5, right? And then you may have already guessed what we're going to multiply the second one times. So we're going to multiply the second one times positive 2, because that's going to make them positive and negative 10, respectively. So 5 times 1.5 is 7.5 plus 10y, equals 100. We're just distributing that 5 on there, right? And for this guy, 2 times 2.5 is 5. So 5x minus 10y equals negative 50. Now that we have 2 of them opposites, then we add up the individual bits for elimination. So 7.5 plus 5 gives us, what is that? I'm telling you, my brain is foggy. It's the afternoon. Don't make me do anything intelligent in the afternoon. I gotta get these videos done though. It's a good thing I have notes to help me stay sanity. 12.5. No, 7.5 plus 5 is 12.5. These, of course, eliminate or cancel, which is what we expect to happen. If that doesn't happen, you done did something wrong. Equals 100 plus negative 50 is positive 50. Now we've got a little one variable, one equation, so we can take and solve this by dividing 12.5 on both sides. That cancels, leaving us with x equals 50 divided by 12.5 is 4. One piece of our puzzle. Now to finish this out, we're going to take and substitute this in. You can substitute it in any one of them. M in for X. I would do it in wherever it looks easiest. In this case, I think we're going to go back up to the first two since we haven't done any multiplication. You could do this one if you don't want to think about fractions at all. Wherever you think looks like the easiest place to plug it back in. I'm going to take it and plug it right there. Okay. So we're going to do 1.5 times. I'm going to plug that 4 in. For x plus 2y equals 20. So we're going to simplify this on down. 1.5 times 4 is 6. Sanity check. They don't even write it. So, yeah, we're going to roll with that. It's 6 plus 2y. We'll see if I get the same answer the book gets for my final answer and see what happens. Get rid of that 6. Of course, we subtract 6 on both sides. That cancels, leaving us with 2y equals 14. Going to divide that 2 off, leaving us with y equals 7. Did we do it? We match. So either I'm wrong and they're wrong, or we're both right. Did you get the same answer? Let me know in the comments below or in class or something else. The answer is ordered pair 4, 7. No big deal, 2 by 2. We're going to throw in one example of a 3 by 3 system. I'm going to write a little bit smaller. I'm going to kind of try to make sure it's legible and all of those things. We got this. We can do it. Then we're going to do one example of an inequality, and then we're going to peace out and be done with this. How are we doing on time? We're doing good. I think we're going to be okay. What is it, example 3? Yes, it is. Example 3. We're going to solve the system. X minus 2y plus z equals 15 and 2x plus 3y minus z equals 7. 4x plus 10y minus 5z equals -3. Blip, blap, blap, blip. There it is. So we could solve this by whatever method we wanted to solve this by. We, in Algebra 2, learned several methods, theoretically. I teach several methods in my Algebra 2 class, and depending on what your background is, you may have learned several methods and whatever else. We're going to kind of do this one, I think, with elimination. I think we're going to go for eliminating the z's. You could solve this by Kramer's rule, or inverse matrices, or substitution, or a combination of those, whatever else. But we're gonna work towards eliminating the z's, I think. So we're gonna start by smashing together. We're gonna label these as, let me label it with a color that I won't use for the rest. This is gonna be called equation number 1, 2, and 3. We'll try to keep this nice and neat and organized. So we're going to stick 1 plus 2 together. Equations 1 and 2. All right, so we're going to eliminate the z's on those. They're already set up for that. That's why I picked z, because this, we just add these two together and z's, poof, gone. So we're going to, I'm going to rewrite it. I'm going to do it in this color. X minus 2y plus z equals 15, and 2x plus 3y minus z equals 7. And then we're going to eliminate. We can just roll with it. Go ahead and add them up. We end up with the equation 3x plus y equals, the z's cancel, of course, and 22. So we've got a little two-variable equation. So now let's look at equations, how about, I think, 1 and 3. And we're still going to eliminate the z's. You have to eliminate the same variable or else they're not going to mesh up in a minute. All right, so let's put 1 and 3 together. So x minus 2y plus z, or z if you prefer, equals 15. And 3 is 4x plus 10y minus 5z equals -3. Now, just like eliminating on a 2x2, we need to get two of them to be opposites. We already picked z, so we got to go with that. So to make these opposites, what we can do is we can multiply this top one by positive 5, because then we have -5 and positive 5, right? So that turns into 5x minus 10y. Ooh, that's looking promising. Look at that. That's going to make our life a lot easier. Plus 5z equals, that'd be 30, 60, 75. Yes, 75 matches the other notes. Clear away, brain fog, clear away. So now we're going to take and eliminate them. 4x plus 5x equals 9x. And ooh, awesome. The y's cancel and the z's cancel. Rock on. Yay, team. -3 plus 75 is 72. Now, we could stick these together and do some elimination, whatever else, but we've got one variable, one equation. Let's go ahead and solve that one for the variable. Let's do it. So we divide the 9 off. So x ends up equaling 8. So now we can substitute that in. Let's take and substitute this one into this guy. That looks nice and easy. So 3 times, I'm going to substitute that 8 in there. Bring down plus y equals 22. So now we can multiply those together. 3 times 8 is 24. We're doing good. Doing good. Ermagerd. Okay. Now we subtract 24, right? I don't know why I'm using that color. That's probably terrible. Let's go back to that. Let's go back to our green note. Our green color. That's probably where we are on this problem. Seems right to me. Minus 24 minus 24. Those cancel, leaving us with y equals -2. So now we just need to find z. So now we can plug x and y into any of the equations. This equation number 1 looks like probably the easiest place to go. So I'm going to branch this off and say we're going to stick it into right there. And then let's grab us an even differenter color and stick and substitute this in for that y. Looks good. So x is 8 minus 2 times, minus 2 times, going to stick our y in there, plus z equals 15. Now let's simplify. So we're going to bring down our 8. -2 times -2 is +4. plus z equals 15. Can we still see that? Yes, we can. Good. We're going to do 8 plus 4, which of course is 12, plus z equals 15. When we subtract off the 12, we end up with z equals 3. So our answer is the ordered triple 8, -2, 3. Nice. Okay. One more example. We're going to do an inequality. We're going to go back to a 2x2, and we're going to solve a system of inequalities by graphing, because inequalities, that's really the only way to solve them, is graphically. So we're going to solve by graphing. This example 4. And we're going to solve y is greater than or equal to 1/2 x minus 3. And y is less than. Let me pause this video and take that phone call. Hold on just a minute. So here I am back. It's a little more than a phone call. Oh, you probably can't hardly hear me, and maybe better. So since I was here a couple minutes ago, or a second or two ago, from your perspective, it's actually on into the night now, and so I don't have afternoon fog. I have late night. I'm an old dude fog, and so let's finish out this problem and then be done with this video so we can both move on with our lives and our math stuff. So let's see. So where were we? Y is less than -2. Let's see. I have my colors. -2 x plus 7. Actually, let me pause and boop in a coordinate grid here, because that's gonna. I was originally just gonna kind of sketch it, but I think it'll be better if we have something to graph it on more proper wise. Give me a boop, and there we go. We are booped. So to remember how to graph these, it's gonna be fairly straightforward. Let's do these in a couple of different colors. I need another layer. Oops. Nope. I don't want to do that. Stop it. Okay, so we're going to do this top one in this orange color, and then this bottom one in this blue color is what I'm going to do. So we start out by essentially graphing these like this was an equals, of course, right? So we're going to graph this first one just like it's any old linear equation. We're going to switch back to orange first, and we're going to graph the y-intercept first. So we're going to go down 1, 2, 3 and put a dot. And then we're going to count our slope. And so we're going to count up 1/2, right? And then up 1/2. We're going to connect the dots here, there. Look, there it is. So there's that graph. Now, first thing, well, yeah, let's continue on and finish the orange one, then we'll do the blue one. So we'll wait for the shading till the end. This equal to makes us have a solid line. So we keep a solid line. I'm not going to erase anything on there. So that one, the line part is done. We need the shading for the greater than part. Let's do the blue one. The blue one, we're going to go up 1, 2, 3, 4, 5, 6, 7 and put our dot. And then we're going to count, because it's negative, we're going to count down 2/1. So I'm going to, this top bit is somewhere down 2/1, down 2/1, down 2/1, down 2/1, down 2/1, down 2/1, and they're right there. So something along those lines. We could have the rest of this as best as I can. So I'm not using a ruler. Now this one is less than, not less than or equal to. So this one actually should be a dotted or dashed line, right? So the easiest way for me to do that is with my eraser. You probably could just slap your ruler down and actually just draw a dashed line. Easy peasy. So there's those bits. Now, we need to figure out where we need to shade. Now, the textbook we're using is excuse me, is very similar to a lot of textbooks for this. And that is that it doesn't it shades all of the regions, but really the true answer to this is where both of these things are true. So for this one is y is greater than or equal to this. So this is the orange one. So the orange one, that would be, if we were going to shade that, let me grab my orange color again, that would be up above. Now remember, on greater than or less than, you're looking at up and down, not left and right. That's even sometimes, even when I say that, that's a point of confusion for students. A lot of times you're looking at either above or below, especially when the line is very steep like this. We're still looking at above or below. So for this one, since it's greater than, we're going to shade above. So that would be up here, right? And then for the blue line, the teal line, whatever you want to call it, it's less than. So that would be below. So that would be down below. So we're only going to shade, for both of these bits, we're only going to shade this pie piece up here. I'm going to put it in both colors because I can, and whatever else, just because it's fun and all of those things. So up in this shaded region is where the answer to the solution to this system of inequalities lives. It's all this space above that one and below that one. That is the answer, and that is it for this video. Thank you for joining us. If you're one of my students, do your homework. I'll see you in class. All the things. If you're not one of my students, thanks for joining us and all of those things. And don't forget to like and comment and subscribe to this channel. Thank you, and have a wonderful day.